So today in math, we are going to be doing just one lesson out of chapter 16, and that's chapter 16, lesson 3, and it's all about line graphs. We've talked about line graphs a little bit in science before, but today we're going to take a look at them for math, okay? And so your learning goal today is to make and interpret line graphs. When we think of line graphs, what do you think in your head? What picture pops up in your mind? When you think of line graphs, what do you think? Ria?
Like a graph where it has different bars.
Okay, so Ria's thinking about different bars, okay. What else pops into your head when you think about a line graph? Think about what we've done in science. Maybe when we were doing the swingers experiment. Daniel?
What pops into my head is that a line with those little bumps in it and
So, first of all, what pops into our minds are axes, right? Lines that look like this. Right? There's, what is this axis called? The x-axis. And then there's a y-axis. Okay. We always have labels for the axes too, right? Why do we need labels? To tell us what the axes are all about, right? So we always have labels here, and we have labels here too. Good. And then Ria said bar graphs, but that would be a bar graph, not a line graph. Line graphs have dots of data, and then those dots are connected. Okay, and that's a line graph. That's called a bar graph. A bar graph is one that you have also axes, right? You have a y-axis and an x-axis, but then you have bars that show the data. Like the elephant graph we looked at, that was a bar graph, wasn't it? A line graph has lines. Okay. Let's look at this. It says, Hannah wore her inline skates at work so she could move quickly around the warehouse. Hannah kept track of the distance she skated. Inline skates are not roller skates, but they're called
Blades.
Rollerblades. Yes, rollerblades. Okay? So Hannah wore rollerblades because she works at a warehouse and she wants to get around quickly. So she kept track of the distance she skated. Each half hour, she wrote down the total number of miles she had skated. So at 8 o'clock, where she got to work, had she skated any miles?
No.
Okay. At 8:30, by 8:30, half an hour later, she skated how many miles?
2.
30 minutes later, what time was it? 9 o'clock, and then she skated 4 miles. What about later at 11:30? By 11:30, how many miles had she skated? 13. So she's just keeping track. And then by 12 o'clock, 4 hours after she got to work, she skated a total of 14 hours. Can we take this data and put it into a line graph?
Yes.
Okay. Okay, so we can turn this data into a line graph. The first thing we need to do, here's that same data up here, right? Same thing. By 12 o'clock, she had skated 14 miles. So to make a line graph, the first thing you need to do is you need to draw the axes. So you'll see here that they drew an x-axis right here and a y-axis here. Then, after you draw the axes, you need to label the horizontal one, also known as the x-axis. And what did they label it? Time. And then they labeled the y-axis with the total miles skated. So you'll notice those labels are the same as right there, right? Time and miles skated. Then it says, this part's important, it says choose an appropriate scale and mark equal intervals. What does that mean when it says choose an appropriate scale and mark equal intervals? What does that mean, Riley?
instead of writing all the times, like 9:30 or 8:30, you just round it to 8 miles.
Okay, so you'll see that they wrote every two, they start at 8 o'clock, and then they had one empty space, and then the next line was 9 o'clock, then an empty space, then 10. Did they space out their hours equally on the graph? Did they do 8 and then 8:30 and then 10 and then 11 and then 12:30? Did they do that?
No.
They made an equal interval. They wrote hour by hour, okay, and they spaced them out equally. Then they did total miles skated over here. And I see it says 0, 2, 4, 6, 8, 10, 12, 14. How come they didn't do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? How come they didn't do that? Hemant?
Did the graph take too long?
Oh, it would take 14 spaces, right? And do we have that much space? How come they didn't do 2, 4, 6, 9, 9, 11, 13, 14 as the scale? Andre?
but that wouldn't be up to scale.
What do you mean up to scale?
Well, if you would do 2, 4, 6, 9, 9, or whatever the
Uh-huh.
number is, the lines would have to have different spaces.
Oh, so the spacing wouldn't be right? So that's what it means by choose an appropriate scale and mark equal interviews. If I did intervals, if I did 0, 2, 4, 6, 9, 9, 11, 13, 14, are those markers, are they equal? What about 0, 2, 4, 6, 8, 10, 12, 14, 16? Is that equal? Because I'm counting by twos. Okay, so once you set up your axes and your, what's this thing called? Scales, then you just write them down, right? Then step 2, it says plot the ordered pairs in red. Okay, so what did they do? They said at 8 o'clock, how many miles did Hannah skate?
0.
So they put a dot at 8 o'clock and 0. Then at 8:30, which is the one in between 8 and 9, how many miles had Hannah skated?
2.
So at 8:30, they put a dot at 8:30 and 2, right? Then at 9 o'clock, how many miles had Hannah skated? How many
4.
miles had Hannah skated?
4.
4. So at 9 o'clock, they put a dot at 4. Okay. Then at 9:30, Daniel, how many miles had Hannah skated?
6.
Okay, 6. It is important to make sure that you always connect your dots to connect the lines to make a line graph. Finally, step 3, you must give your graph a title. What is the title of this graph? Distance skated. There's the graph title. Okay. Now, sometimes you can have a double line graph to show 2 different amounts of data. Okay, so let's look at this situation. It says Manish also works at the same warehouse as Hannah. Okay, he also kept track of the distance he skated around the warehouse. So here, you notice Manish also kept track of his data from 8 o'clock all the way to 12 o'clock, but he skated different amounts than Hannah, right? So it says you can make a double line graph to compare 2 sets of data over time. So this red one, you need a key now to show that the red is Hannah and the blue line is Manish. Okay, and so they did the same thing. So just by looking at this graph, if the red is Hannah and the blue is Manish, who skated more miles all in all?
Yeah.
Because you can see that for every time, Hannah has skated more than Manish, right? Okay, so by having a double line graph, you can compare 2 sets of data by looking at one thing because you have different colored lines. When you have a double line graph, what do you need to make sure you have? A key, so that you know who you're looking at and what you're looking at. Excuse me.